Okay, welcome everybody. My name's Chris Gregg. I'm the Director of the Energy Initiative and the Dow Centre for Sustainable Engineering Innovation here at the University. And it's my pleasure to welcome you to this evening's Energy Express seminar. Firstly, I'd like to acknowledge the traditional owners of this place in which we gather and pay our respects to their elders past and present. Tonight we're going to be given a presentation by Stephen Wilson. Stephen is the Managing Director of Cape Otway Associates. Stephen had an almost 30-year career in the energy sector. He commenced life as a mechanical engineer, but soon found his way to become an energy economist and worked in various consulting firms in Melbourne, Hong Kong, London, in about 35 countries, advising financial institutions, corporations, regulators and governments. His most recent role after coming back from London was as the head of the industry analysis group at Rio Tinto Energy, where he had that role for about 5 years, and then more recently has become a consultant again. In July this year, he became an adjunct professor at the University of Queensland Energy Initiative, and so it's been really great working with him just in the last year or so. I'm not going to say too much more about tonight's presentation, but I hope you enjoy it, and I'll hand over now to Stephen. By the way, we'll go for about 35 minutes, then there'll be about 20 minutes of Q&A, which I'll moderate, and then we'll have some nibbles and drinks outside.
Thanks, Chris. So I'm going to talk this evening about renewables and competitive markets, or renewable energy in competitive markets, and the analogy is of a three-act play. Act one is the transition is underway. This was the phase of great enthusiasm. And the market is catalysed and starts to change, and everyone's feeling pretty good about things. Act two is titled, "Is the market dead or just resting?" And that's when the first problems start to emerge, and I think we're more or less in Act 2 at the moment, which you'll see when we come into the detail. And then Act 3 is a chaotic journey back to the future. So I just want to plant a couple of questions in your mind at the outset. One of them is, and I'll develop these themes as we go through, one of them is, does variable renewable energy, wind and solar, really lead to lower prices? And the second one is subsidising of electricity generation really compatible with competitive electricity markets? So let's get into it. It's a play, so we've got a cast of characters. We've got 5 prime ministers here and various other assorted people. Mr. Howard was prime minister in the early stages of the launch of the competitive market, and of course in the early stages of incentivising renewable energy. And I think, it'd be unfair to say that his prime ministership sort of hit the rocks on the issue of climate change, but I think it was an issue with which his government wrestled and perhaps never quite fully came to terms. His successor, Kevin Rudd, famously said, climate change is the greatest moral challenge of our time, until the failure of the Copenhagen summit, after which he hardly mentioned it again. So climate change was sort of a big theme of his prime ministership. And then his successor, Julia Gillard, famously promised never to introduce a carbon tax, and then when she failed to secure a majority in the election, found herself negotiating with Bob Brown, who made that one of the conditions of supporting her minority government. And so that was the background to the introduction of the carbon tax in Australia. Of course, Tony Abbott famously said in a town hall somewhere in Western Victoria, climate change is crap. And of course, while opposition leader challenged challenged Malcolm Turnbull for the leadership very much over this issue, which was dividing the party room, and won the leadership by one vote. He had his struggles, I think, dealing with this issue when he became Prime Minister. He wasn't quite sure if he wanted to abolish the RET or not, and in the end it was scaled back but not abolished. And then, of course, he's subsequently been replaced by a man whose beliefs in this area have perhaps been modified in recent times. They're a little different than they were when he was back in the day when he was opposition leader. Dr. Finkel, our chief scientist, is in our cast of characters, having recently written a major report grappling with some of the problems and challenges in the electricity market. We have, of course, the opposition leader, the energy minister, the Premier of South Australia, and the Minister for Resources, who's very keen on new coal-fired power plants, believes we need some new coal-fired power plants in Australia. The leader, Deputy Prime Minister and leader of the Nationals, of course, is wrestling with the issues between the energy sector and the farming sector around resources and water and all of those things. And then, of course, we have the battery guy who launched himself very famously onto the scene recently after the South Australian blackout. So the transition's underway. In Act 1, the catalyst for kicking off renewable energy was, I think, the renewable energy target, which started off, you might remember, as a 2% target on an energy basis, with the idea of supporting renewables, and that was introduced alongside the competitive electricity market, alongside the NEM. So effectively, in that scheme, you've effectively got zero marginal cost resources coming into the system and, in effect, having dispatch priority. Then, of course, the government changed and introduced a carbon tax. Then the RET was supercharged to 20%, but what they did, of course, was they took the demand forecast, multiplied it by 20%, and wrote that number, 41,000 gigawatt hours, into the legislation. Then demand growth fell short of those projections. And just to refresh your memory, in the Finkel report, they put a nice summary of the history of the demand forecast. So the actual is the black line, and then those little dotted lines are the various historical demand forecasts. So you can see that, of course, turning points are very difficult to forecast, and this is a good example of the challenge of forecasting turning points. There's at least 5 factors that have been causing this, which I've listed there. And you can see that in the most recent forecasts, they're basically almost flat lines. Then, of course, the government changed again. The carbon tax was repealed, so we've got this constantly shifting landscape of changing policy. And, of course, investors are investing and surging towards meeting that 41,000 gigawatt hour target, which is driving demand for renewables. And it becomes clear that that's going to be more than 20%. And then wind is dominating the large-scale renewables, the grid-connected renewables, and it's becoming proportionately concentrated in South Australia relative to the size of the demand in South Australia, because of the quality of the wind resources down there on the Yorke Peninsula and the Eyre Peninsula. But of course, we're in a market with flattening demand, so the market doesn't really need any new capacity, but it's being essentially force-fed this new capacity. So that shifts the short-run marginal cost curve for electricity generation to the right, and that has the effect of suppressing wholesale prices. So this is pushing us into a world of sort of $30 to $50 per megawatt hour prices as being typical around that time. And then, of course, there was the RET review, the Warburton review, and the result of that was a kind of political compromise where the target was reduced from 41,000 gigawatt hours per year to 33,000 by 2020, and then flat out to 2030. So in scene 2 of Act 1, old coal plants start to fall off the perch. Of course, at the same time, we've seen network revenues doubling as the increased requirements for network investment have flowed through into prices. And of course, as you probably know, there's been at least 20, I think maybe more than 20 appeals against regulatory decisions by the network owners, and they've won on every occasion. And then the market for large generator certificates under the renewable energy target starts to tighten. And with the uncertainty at the time of the review holding back the new investment, of course, the market tightens even more. So the prices surge and they go towards the tax-adjusted penalty for non-compliance. And then as this process is playing out, capacity factors on coal-fired power plants are being pushed downwards. And then some plants find that they need to bid negative prices at times because they want to avoid shutting down and starting up again. And so these factors are driving increasing volatility, increasing price volatility, and we're starting to see extreme high prices in the market, even as the average prices have been declining. And then with the erosion of revenues for the baseload generators, eventually some of them start to close, and we've seen that happen in New South Wales, we've seen it happen in South Australia, and we've now seen it happen in Victoria. In the case of South Australia, the government was offered by the owner of the Northern Power Plant to keep that plant available if needed for a fixed annual fee of $25 million, but the South Australian government declined that offer. So of course they've got no coal-fired power plants left, and they're relying on Victorian baseload brown coal for their baseload supply when the renewables are not able to meet demand. And then another thing that's happening throughout this process is that the challenge of balancing the system is becoming more difficult. So I think one of the things that a lot of people forget is that the electricity system needs to be balanced not on an annual basis, not on an annual energy basis, but every 1/10 of a second in effect. Supply and demand have to be precisely balanced with each other in every part of the system, and if that doesn't happen, then there's serious problems. So in response to this, we're seeing more need for open cycle gas, and we're seeing investment in small diesels, particularly in places like South Australia. So what are the effects of this? What are the effects of these increased wind and solar generation, pushing down coal capacity factors? What I want to do is just look at the case study of South Australia. So this is a paper that was written last year by a couple of guys at the Melbourne Energy Institute, and they kindly lent me the data files which they'd obtained from AEMO. So this is the 2015-16 financial year. So that's the South Australian load duration curve for that 12-month period. So you've got all 8,760 hours are there, sorted from the hour of maximum demand to the hour of minimum demand. The peak as it happened was just short of 3 gigawatts, and the authors use a 10% definition for peak. So on that basis, you need about a little over a gigawatt of peak capacity to meet that load shape. The min demand 690, and so baseload requirement of 690 gigawatts, and an intermediate of a little over a gigawatt. So the traditional way that you would meet that kind of load shape, if you were just cost minimizing, is you'd have coal in the base load, and then as you move up into intermediate, you'd have gas, with a sort of fuzzy distinction there, as I've indicated it. And then in the peak, you'd have either open cycle gas turbine, or you might have some small diesels meeting the peak. Now, what happens if you net off the wind generation? So the top curve here is the same one we just saw, and the second curve is taking the hour by hour or the half-hourly load right throughout the year and then subtracting the wind in each of those half hours and then resorting so we still get a smooth curve. Interestingly, on the hour of maximum demand, there was hardly any reduction or hardly any contribution from wind. It was only 65 megawatts. The change in the load shape actually increases the amount of peak generation that you need, and you can see that's about a 20% increase in the amount of peak capacity using the same peak definition. The intermediate goes all the way to zero and actually beyond zero. So you actually end up with negative base load. So there's a few hours of the year where, in that particular year, where South Australia's wind generation was greater than its load, and so the excess needed to be exported eastward into the Victorian system. So what's happening is, I think the key point here is that the value of the wind is really just an energy value. So you can't really compare its economic value with the full long-run marginal cost of alternatives. You can really only compare it with the short-run marginal cost of what it's generating, because it doesn't actually reduce your need for peak capacity or for installed capacity. But you can see how it changes the way the system's dispatched. You'll tend to have a lot less coal dispatched, tend to have more gas. Can we get the gas is an issue, as you know, and I'll touch on that, and probably a bit more diesel. So that's the kind of dynamic that drove the closure of Playford and the closure of Northern Power Station in South Australia. What this chart shows is the cost structure of different generation plants. So you've got everything from coal through gas, combined cycle and open cycle, up to diesel. The intercept on the left-hand axis is the annualised value of the capital cost of each of those types of generation capacity. So, and that's, I think that's been done with a WACC of 6% real. So that's essentially the annual charge that you would need to pay, that the investor would need to receive in order for it to make sense to make the capital investment, even if the plant was never dispatched. And then the slope of each line represents the operating cost, the variable operating cost, and the fuel cost for each of those technologies. There's no carbon price assumed here. I've shown there on the right the particular fuel cost assumptions underneath this chart, but of course if you change those fuel prices, then the slope of the lines would move accordingly. And of course if you added a carbon price, the steepness of the line would go up accordingly based on the carbon intensity of the particular fuel that you were using and the thermal efficiency of the plant. So what if we now map this onto our load duration curve that we were looking at before? So there's our load duration curves, just like we looked at before. What this shows is that the base load plant is the most economic, so it's the lowest cost from maximum generation per year, which is about sort of 85–90%. I think I'm showing 91% here, 8,000 hours a year, down to for brown coal, it's down to about 65%, and for black coal, it comes even a little bit lower. So on a pure cost basis, that's the way you would traditionally dispatch against a load shape like this. Then next, you come to gas, which is the blue line, and you can see that there's, I've indicated a little bit of overlap, which is actually between the gas and the black and brown coal. And then finally, for the peak hours, you come to the open cycle gas turbine, the orange line, which fills the rest of the load shape. So there's a few, this is just, I think a lot of you will be familiar with this. This is how they used to actually plan systems in the days before they had computer optimization programs. A few interesting things to note. One is that even though the overlap ranges on the bottom chart are quite wide, when you project them up onto the load shape, the overlap range is actually quite small in how you would optimally dispatch against the load shape. What if we then take those straight lines and then divide them by the number of hours at each point along the curve? So if we do that, this is what the chart looks like. So this is now on $1 per megawatt hour basis, rather than a cost per unit of capacity over the number of hours per year. So you can see the crossover points are actually the same. And what you're looking at here is a chart of LCOE as a function of capacity factor. or operating hours per year. So when you read reports that show you LCOEs, usually what they're doing is they're showing you some numbers, these numbers here, and I've labelled the endpoints on each of these curves. Sometimes what they'll do is they'll take a point here for one of these technologies, and then for this technology they might take a point somewhere here. So you need to be aware of that when you're looking at LCOE numbers. It's often not clearly spelled out. So back to our play, is the market dead or is it just resting? We're starting to see worrying signs. At the same time that we've got an electricity crisis unfolding, we've got a gas crisis simultaneously. I think probably most of you are familiar, being here in Queensland, what's happened in the gas market. The domestic market of about 600 petajoules has just had this enormous additional export demand placed on it. That sort of demand shock is probably some sort of world record, I expect. You can see the grey section there is domestic gas-fired power generation, and you can see how that has shrunk in response to the export LNG demand. South Australian prices, of course, surged about 12 months ago, and they started, before the blackout, they regularly started spiking up towards the market price cap, and you can actually see that on this nice chart which AEMO put together recently. So the bottom line there is 2014-15, the top line 2015-16, and the colours represent the plant type that was setting the price in each of those half-hour price periods for the year. There's similar charts to this for the other states. But notice that the $300 prices are exceeding $300 about 5% of the time, which is pretty stunning. Then plant closures started to tighten the market. And of course, the high gas prices have exacerbated that. You know, you've got $10 gas, you're looking at, in an open cycle gas turbine, you're looking at sort of $100 per megawatt hour electricity just on a fuel cost basis. System balancing becomes really challenging. And then, you know, you have a situation where actually, even when you've got high output from wind, you've still got to be running synchronous generators for balancing requirements, and that's reflected in the updated AEMO rules. For example, in South Australia, even if the wind exceeds the total state demand, they still have to have at least 2 units operating, just so they can make sure the system is secure and reliable. So what we're seeing here is that the underlying cost structure is actually starting to be reflected in market prices. So in Act 1, we were sort of obscured from the underlying cost structure. We saw prices were being forced downwards. Everyone said, isn't this great? Renewables drive prices down. But actually, that was just reflective of a sort of artificial situation of excess capacity in the market. Whereas now, we're starting to see the economics reflected in the market prices, and worse. And then, of course, we had the first statewide blackout since 1964 hit South Australia, and then the proverbial hit the fan. The damage for that is something in the order of $400 million, give or take $50 million, depending whose estimate you want to believe, which starts to make the $25 million per year offer to keep Northern Power Plant available look pretty cheap. So we've got this situation where the market is struggling to resolve the 3 objectives of reliability, affordability, and sustainability. So time to call for the doctor. And so the government called in the chief scientist, and the Prime Minister stood up at the press club and started talking about coal-fired power plants. You might have seen signs like this in your travels. This is the kind of problem that we have in the energy sector. Of course, we're trying to achieve 3 things at the same time, and you know, there's no mathematical function that can do that. So these 3 things are in tension, and the only way to resolve them is with judgment, with political solutions, and so on. So we want these sort of 3 abilities. Coal is pretty good at delivering affordable, reliable power, but sustainability is a bit of an issue. For gas, reliability and sustainability are its strengths, but affordability is quite a problem and an increasing problem in Australia. The renewables are big on sustainability, but struggle pretty seriously with reliability and affordability. Nuclear, of course, has been touted as the answer to this trilemma, and the Chinese look like they'd crack that problem, although the problems they're having with their Gen 3 reactors maybe we were a little bit too optimistic. And then, of course, here in Australia, we're not allowed to use coal. People don't like gas. Of course, nuclear is illegal, and we're, I think, decades away from having community support that would make nuclear possible. What about hydro? Well, we stopped that in 1983 when Bob Brown was a young campaigner. So what about the demand side? This is all supply side. Smart meters. Smart meters, some people say, are the answer. Smart grid and smart meters. Well, the Victorian government legislated that everyone must have a smart meter, and then a popular movement rose up, deeply suspicious of this, and they've basically prevented the compulsory use of smart meters for time of use pricing. So my question is, or one of my questions is it politically plausible to have an affordable, sustainable system that doesn't deliver reliable power? And another question is it socially acceptable to have a sustainable, reliable system that can't deliver affordable electricity? This is a lovely quote from one of the very senior energy policymakers in Japan. He said this a few years ago at a high-level government meeting, actually. And that's the reason that most countries have a mix. So because there's no one fuel that can deliver all three objectives, and so a mix is needed and some sort of compromise is required. So our worst fears are starting to be confirmed. We've seen the closing of Hazelwood, and in case you were wondering how serious Engie was about not wanting anybody ever to bring this power plant back online, those cables which they cut, I think, tell that story. That's a picture taken by one of the workers decommissioning the plant. We've seen wholesale prices double. You can see, I mentioned earlier that we went, in Act 1, we went into a sort of $30 to $50 world, which was basically pricing the short-run marginal cost of the legacy coal fleet, in effect, in New South Wales, Queensland and Victoria. We're now in a sort of $80 to $140 world, very different kind of world in Act 2. Generators are starting to become really profitable after struggling for years. So the profit pool is sort of sloshing from the retail market into the wholesale market. No one can produce a bankable price forecast. I've recently had the privilege of talking to virtually all the major Australian banks and all the, most of the international banks that are present here in Australia, and they all tell you the same thing. No one can produce a bankable price forecast. I mean, you can come and put one on the table, but they won't believe it. And we've seen the price forecasts produced, a year or two ago. They were all completely wrong. None of them forecast that chart that I just showed you. So what that means is you can't get a loan for any new generation project. It doesn't matter if it's coal, gas, renewables or whatever, unless you've got a 15-year PPA or something that looks very much like that. We're still seeing renewable costs falling as we go forward. And the new renewable energy is still, we've still got a RET, we're still short of the target, so that's still driving investment. But meanwhile, prices are now continuing to rise and reliability is falling. So the wholesale price pool's basically doubled in size. A $9 billion market is now a $16 billion market, nominal based on market prices. And people are starting to demand that the government does something about this. There was a great quote at the Engineers Conference in November from Dr. Tim Stone from the UK, and he said, "Governments own failure." And I think it's very true in the electricity sector. So even though the 1990s philosophy was that we'll just leave it to the market, now as soon as there's problems, the voters demand that the government solves the problem. They can't just say, oh no, that's just the market, that's nothing to do with us. And we're starting to see that, right? We saw that with the South Australian government response to the blackout. They suddenly said, we're going to build a new gas-fired power plant. Then AGL said, well, we'll just tear up those plans that we were making. So my question, is the competitive market dead? Or is it just resting? It's a Norwegian blue. And secondarily, are we returning to central planning? I mean, this is where we've come from. How did we get to where we are and where are we going? This is the sort of the journey of Australia, and it's probably quite similar in a lot of other countries. You know, we started with these small municipal power stations basically in the centre of cities. You know, there was a power station in Spencer Street in Melbourne years ago. And then by the sort of 20s and 30s, those guys were just not able to meet the people's demand for electricity. And so people screamed and said, you know, we need electricity. And so the government stepped in. And so we moved from a private market environment to a state-owned and centrally planned electricity sector. You know, Sir John Monash in Victoria came back from World War I and went out and built the State Electricity Commission. In New South Wales, Sir William Hudson, you know, these guys are sort of great engineers, right, of the country, went and built the Snowy scheme. And then we said, oh, that all became very inefficient and terribly sort of hidebound, and so we needed to introduce competitive markets. And so we sort of muddled our way along into a national competitive market with a kind of combination of private ownership and state ownership. We've moved to more and more private ownership. We've seen more privatisations recently, particularly in places like New South Wales, although not here in Queensland so much. And arguably we're seeing a less competitive market at the same time as it's become a more privately owned market. But are we going back to central planning, I think, is a serious question. Now, interestingly, there's very little debate about this. There's all kinds of debate about renewables and should we build coal, or, you know, can we have a 100% renewable system or not, and how much pump storage do we need, et cetera, et cetera. But what we had in the 1990s was this very broad political and social consensus across both major parties, between the states and the federal government, you know, the Hilmer, Keating, Kennett, Howard consensus, a huge social consensus. And that's basically being trampled underfoot, and no one seems to be talking about it. Politicians keep saying we just need reliable, affordable, sustainable power. It's like, yes, but there's no technology anywhere on the face of the earth that can actually deliver that. So there's a sort of terrible fight going on between left and right, between states and the federal government. We've got inquiries multiplying. Finkel proposed to put the consumer at the centre of the trilemma in his preliminary report, but he didn't really follow that through in his final report. And no one's really able to, there's no statesman, it would seem, at the moment who's actually able to resolve this problem. And so we're sort of sleepwalking into a situation where the government is basically finding itself as the investor of last resort for power generation. And meanwhile, our coal and gas fleet is not getting any younger, and it's basically about to fall off a cliff sometime in the foreseeable future. So if you look at the retirement schedule for the coal and gas-fired power plants in Victoria, it looks like that. You can see the hashed red area is the early retirements that we've seen already. In New South Wales, it looks like that. In Queensland's not so bad. The fleet's quite a bit younger here. It looks like that in Queensland. So after the cliff, what's the outlook for sun and wind-powered decarbonisation? What I'm showing on this chart is this is taking levelised cost or long-run marginal costs of new technologies and the short-run marginal cost of the existing plants. Okay, And it's looking at, so the x-axis is the emission intensity of each of these technologies, and the y-axis is the cost per megawatt hour of generation from each of these technologies on a baseload basis, right, on a high capacity factor basis. So just sort of enlarging that chart slightly. They're the 1970s and 1980s lignite fleet, the Victorian fleet, the legacy fleet. Hazelwood has already retired, the highest emissions intensity plant. The ones to the left there are the black coal fleet in New South Wales and Queensland, basically built in the 1990s and 2000s, some a little bit older, such as Liddell, which is the rightmost one in the box there. The triangles are Queensland plants, and the square boxes are the New South Wales plants. Of course, we'd love to be in this corner, right? We'd love to have zero emission electricity that was free, but that, of course, is impossible. We don't want to be in the high emission, high cost corner, so that's redundant. And the top left corner is basically unaffordable. And so the interesting thing you'll notice about this chart is that it doesn't really matter what kind of low carbon technologies you're looking at, whether you're looking at coal with CCS, whether you're looking at nuclear, whether you're looking at renewables with some sort of storage or backup. They're all up in that sort of there or thereabouts, up in that very expensive top left-hand corner. You know, once you start adding pumped hydro to wind, it's really expensive. If you've seen my paper for EPA, you'll know that when you look at solar and batteries, it's basically right off this chart. If you back it up with gas, of course, then you've increased the emissions again. And then you're off the efficient frontier. So the efficient frontier is that line, which is the closest you can get to the bottom left-hand corner. The government is looking at high-efficiency, low-emission coal. And maybe in the future, one of the strategies could be build high-efficiency, low-emissions coal now with a pathway to CCS in the future so that you could move, as and when it became appropriate internationally, up towards the top left-hand corner of the chart. So I think I'll stop there, Chris, and hand it back to you for questions.
Thanks, Stephen. So we're going to have time for some Q&A, and we have at least one roving microphone available. So I might ask one question while there's a question up there. If you can get the microphone, put your hand up again. But in the meantime, one of the questions you posed at the beginning was, can subsidised generation, which I assume you mean through the RET, is that compatible with competitive markets? And the Chief Scientist has now introduced, or is proposing, a clean energy target, which would ultimately replace the renewable energy target, so basically a technology neutral version thereof. Would that be more compatible, or could that be compatible with the competitive electricity market?
It's a great question. I think the economist in me says no, because you know, whenever you introduce a subsidy, you're distorting things and you end up with unintended consequences. And I think we're seeing some of those unintended consequences already. You know, we've seen it in the prices, which were not forecast. You see it in Germany. You know, in Germany, basically they're using diesel to pump water uphill in Austria. You know, that's an unintended consequence of a renewable energy policy. It's kind of not exactly the Great Green Revolution. So I think it's problematic, is the short answer, Chris. And I think, you know, the clean energy, it's not entirely clear how the clean energy target will work, but it's going to involve a very complex set of trade-offs between, you know, the demand for these certificates, the supply of them, you know, where the line is drawn, how the price comes out. And I think it's going to compete. One of the big problems with the RET, and I mentioned this in my EPA paper in February, is that the principles underneath the RET are 180 degrees opposed to the design principles of the NEM. And I think we'll probably see the same problem with the clean energy target.
So we have a couple of questions up in the top right-hand corner.
So, Graham Taylor here from Best Futures. On Sunday, Professor Stephen Hawkins said in an interview with the BBC that he was talking in reference to the Trump administration's decision to withdraw from the Paris agreements. And he said that the world is approaching these climate tipping points where we are likely to have irreversible runaway climate change. And if we pass this, the temperature on Earth could approach that of Venus of around 250 degrees Celsius, and it'd be raining sulfuric acid. Now, it seems to me that part of the problem, or part of the discussion that we have to have when we talk about energy, is the fact that we have a risk problem here, which is the threat of catastrophic climate change, and that is going to force the world to start looking at things like geoengineering on one hand, but on the other hand, carbon taxes. They're going to be coming in because the world is going to have to reduce fossil fuel emissions in order to prevent catastrophic environmental degradation. So it seems to me that we're seeing these investments coming in and into renewables. We're starting to, Bill Gates is talking about, anyway, there's a whole range of new technologies coming out there. And prices will come down, and solutions will be found if enough money is put into it on a crash basis. So how are you factoring this into, when you're looking at these different options, how are you factoring in some of the timelines that, for example, some of the top environmental figures in the world, people in the world, like Christine Figueres, just made the statement that we have to start reducing emissions by 2020 or the world is in trouble. So how is that going to factor into this political mix and economic mix?
Yeah, that's a great question, and it's clearly beyond the scope of the topic here, which is the problems in the renewables market, the problems between renewables and the competitive electricity market. I think, what we're seeing when people try and solve these problems with renewable energy, we're basically seeing a sort of form of socialisation of a set of costs. And you're quite right that it's a risk management problem. I mean, it's a classic problem of decision-making under uncertainty. But from 1989, on the 8th of November 1989, Margaret Thatcher stood up in the United Nations and she made a speech that, if you read that speech, 4,000 words of it, it's like it was delivered yesterday. It's got all the messages that you hear every day. And she delivered it that day. Everyone's forgotten it because the next day the Berlin Wall fell down. But she said a whole lot of things that, she said we need a huge global collaborative effort. And we've sort of been trying that for 25 years and we haven't really succeeded. And she basically said, we can't do pledge and review, that won't get us there. And guess what? So we tried Kyoto and we tried all these other things, and we've come right back to INDCs, which is basically pledge and review. So we've basically spent 25 years going around in a circle, getting nowhere. We're just starting to talk about how much capital should we reserve, how much capital should we spend on mitigation, how much should we reserve for adaptation, how much for compensation. These are huge problems, but I think that the big message that has been pushed by a lot of people and a lot of people in the media is that, this is actually really simple and easy to deal with. It's just like, sulfur trading in the US. But it's not just like sulfur trading in the US. It's actually much more difficult, much more expensive. And there's a huge prisoner's dilemma problem where everyone's incentivized to essentially cheat, right? So, no one's own individual actions can solve the problem, and actually the best outcome is if everyone else does something and then you don't. And so that's basically what every country in the world's been doing for the last 25 years, wrapped up with these highly sophisticated negotiations and everything. So if you believe Stephen Hawking's climate sensitivity number is obviously way off the scale to what the IPCC is talking about. If he's talking about 250 degrees, not 8.5 degrees, which is the IPCC's kind of disaster scenario. I mean, if you believe that, then probably, I don't know, just get some whiskey.
So we got a question in front, and then we've got one down here next. David, put your hand up just so you... This one down here first. Yep. And then you go, yep. Go ahead.
Thanks for the presentation. I had a specific doubt in one of the slides when you showed the triangle, putting like sustainability, reliability, and affordability. So you put renewables only in the sustainability corner, but I think one or two slides after that you mentioned about the prices, benefits of renewables. So I don't know if I had like a bad impression of if I didn't read like the slides after that correctly, or if you meant just for a certain range of power that like the good price of renewables. So could you explain a little bit more like why you put like renewables on like only in the sustainability corner and not a little bit on the affordability?
Yeah.
Thanks.
So when I do that, I'm taking a whole system perspective. So if you just look at the levelized cost of renewable energy, so the cost of making a megawatt hour, that's come down enormously in the last 2-3 decades, and it's continuing, you know, there's a continuing learning curve. So those costs continue to fall. But the problem is that once you start getting to high shares of renewables in a power system, you start incurring lots of other costs, and those other costs have been obscured. So essentially, they've been placed onto someone else. But once you get to once you go from sort of 5% to 50%, suddenly you can't pretend those costs don't exist anymore. And when you actually do the numbers and you say, right, I've got to balance this system every 1/10 of a second. I've got to keep the frequency within half a hertz of 50 hertz and balance it every 1/10 of a second. How am I going to do that? The kind of investments you need to make to do that are really substantial. And so even though the cost on a sort of technology level is coming down, your system costs go up enormously. That's the problem.
So we've got David and then Mark.
Thanks, Stephen. An excellent presentation on the absolute complexities of the supply side. But on the demand side, I mean, I did a lot of work about 10 years ago in energy efficiency and the lack of uptake of energy efficiency. What role could, you know, really deep energy efficiency provide, and more demand management, more time of use pricing and things like that in trying to solve this?
Yeah. It's a great question. So I started my career in energy efficiency in 1991 or something, 1991 or 92. So I did nothing but energy efficiency for the first 6 years of my career. I was working for, you know, an American hippie who'd become a consultant, and I was saving the world, right? So we designed all the energy efficiency programs for the Victorian government, and we did work for New South Wales and Queensland and, you know, Western Australia and South Australia and around Asia. So yeah, energy efficiency is really important. The IEA reckons that it has to carry 45% of the burden of climate, you know, meeting the climate challenge. There's always improving technology and there's always opportunities. It's not easy because you're dealing with human beings, decision makers, people who've got other priorities. Transaction costs are almost always underestimated. Right, management time is actually expensive. But I think, having said that, you know, so I lived through, in those first 6 years, I lived through sort of the energy efficiency enthusiasm and then the arrival of competitive markets. And I basically said in 93 or 94, either competitive markets will kill energy efficiency stone dead, or people will get really serious about climate change and energy efficiency will be a big thing. So it's turned out to be B, right, not A. I think that's pretty clear. I mean, we were trying to tell retailers in the 90s, look, you know, you're much better off selling a package to a customer where you help them reduce their bill and you keep 80% of what you were selling them than to lose them to someone else. And the utilities were like, get lost, you know, sort of. They didn't want to know, right? But then by the time I was living in London in, you know, sort of 2003 to 2010, you know, the ads on the tube from all the electricity companies was all about that pitch. It was all about, we can help reduce your bill with energy efficiency, blah, blah, blah. So I think it's got a great role to play. It's the main reason that energy is sort of at least somewhat delinked from GDP growth. And we can get a lot smarter about design. I think if we design buildings well at the front end, instead of coming back and retrofitting them later. Oh yeah, I mean, yeah, all that stuff needs to come. Yeah, but yeah, I mean, you saw the story from Victoria. Yeah, yeah, you've got to be able to sell it and bring people on the journey. Yeah.
Question for Mark. Mark Patterson.
As an economist, you probably like an unfettered market, but the entire NEM is a big synthetic construct.
Yeah.
So, as Prime Minister, how would you set it up differently?
Great question. I'm not running for Prime Minister.
You've got 7 minutes.
Yeah, I think, yeah, I wouldn't go as far as you maybe think I might in terms of being a purist and thinking unfettered markets are just the answer to everything, because in electricity, in the case of electricity, it's clear that it's a very complex industry. As you say, you've got to synthetically create the market. It's not like a fruit and veg market. And there's always a role for government, because people will always blame the government if the lights go out. And then you've got the problem of oligopoly, right? You need a lot of players to actually have a genuine competitive market. And do we really have that in Australia at the moment? It's getting more and more difficult I think, to make the case that it's a truly competitive market. So I think what is needed in electricity is not ideology and sort of pure textbook solutions, but practical, common sense approaches that recognise the technical engineering nature of the system, its importance to the economy, and within that try and provide the right incentives for people to deliver the service efficiently. So I haven't got an easy sort of off the bat answer for you, but within that sort of philosophy, I think, is where I would try and find the answer.
Then we've got a question at the back. Paul, I think it is.
Hi, Paul Bell, Department of State Development. Just talking about the market as coordinating device, as an economist as well, if we introduce a 5-minute settlement period, this would allow coordination between the generators and the consumers to better match supply, because at the moment the half-hour settlement period is suitable for the old system with coal-fired power stations and gas, where things could move fairly slowly. But quite rightly, as you point out, with the variable renewable energy, we need much faster response. And with a 5-minute settlement period, this would allow batteries and other devices which are more expensive to operate to recoup those peaks or spikes in prices that occur for very short periods of time. And that would be one way for the market to operate more efficiently, as well as introducing time of use and time of supply in smaller increments as well. It's been done in other countries, but you made a point about Victoria, how it didn't go down too well. And that was mainly because we allowed engineers to do it for us, and engineers are not particularly good at customer relations. So if we're to ever try and crack this one, we've got to have people involved who are marketers and these types of people, fuzzy, warm people who will do nice things and talk to people and find out what they really want, rather than just giving somebody a set, fixed solution and then pull. What happened there, they actually pulled the in-house devices at the last minute, which they'd promised to people, and they got very upset, and they would be given bills, astronomical bills, and they had no way of responding to this time of use. So I think that's a really poor example of how to implement a smart meter service. In fact, the world should observe Victoria as a good example of what not to do.
Yeah.
So I think that was unfortunate. The other aspect, I quite agree with you with the total lack of competition in Australia. We seem to have a perverse situation where we have 26 network service providers, which are all natural monopolies, which is absurd to have 26 CEOs and boards of directors running a natural monopoly that's for the entire country. And while we've got 3 main big retail generators, which are gaming the market and can bypass the RET by charging the consumers more and just paying the fine, and because they own the coal generators, they can just pass the profits between the retail section and the generation section, and basically undermine the whole RET system. So we've got heaps of problems in our electricity system, and I think with proper use of simple market devices, we can solve some of them. Okay, I'll stop there. Thank you.
I think Brian at the front here. Oh, sorry, yeah, you go first, and then we'll then pass it over.
G'day, Stephen. Bob Graham from Jacobs. I just had a question. I gathered that the punchline at the end was the replacement for coal is likely to be the high efficiency, low emissions with a pathway to combined capture and storage, carbon capture and storage. The thing that puzzled me with this, I just wanted your comment on whether this is actually what you endorsed, is that that pathway still leaves carbon capture and storage having to take carbon out of the vast stream of nitrogen that goes through the normal cycle, as opposed to the IGCC, the integrated gasification and combined cycle, which avoids that step and which was the sort of pathway to carbon capture and storage about 10 years ago. If you could just comment on that change, please.
Yeah, I'm not sort of endorsing one particular approach, but I think that's something that should be considered and discussed. As to which technology, whether you go ultra supercritical or IGCC, I mean, there's actually pros and cons of both. You know, neither of them are perfect and ideal in every aspect. It's like most things in life, there's a trade-off. But I think what seems to me fairly clear is that if we are not going to have nuclear in Australia, and if we've got enormous export pressure on gas and enormous community opposition to gas production, putting all the eggs in the gas basket seems like a pretty long shot at the moment. And when you look at the shape of the load shape, the one I showed was the South Australian load shape, but actually if you look at the whole NEM, the baseload rectangle is like 65–70% of the energy and of the revenues. And if you look at the crossover point where the optimal is, you're a lot further up than that. So you're talking about, at least 80%, if not more, of the energy is currently served by coal and is economically optimally served by coal. And if you try and, if you dial up a carbon price, you're going to drive up the gas price. So that all those curves will move and the intersection points will move, but it's like a dog chasing its tail. So it's not easy. We've got to stop pretending it's easy.
Yeah, excellent presentation. I really enjoyed it. But we all know how quickly 20 years goes, and I just wonder what you've done at looking at primary energy in terms of coal, looking at your primary energy in particularly New South Wales. We've already, AGL has said they're going to shut their power stations, but I think New South Wales is going to run out of coal in that period anyhow. And in terms of available coal for domestic power.
Yeah.
And so where else? Where do you go in 20 years' time, or within the next 20 years, for baseload power? If you haven't got coal, so it's all right to have Hurley power station. If you haven't got the coal, what do you do then?
Well, I think from a geological point of view, there's abundant coal in Australia. I mean, the Latrobe Valley has got vast reserves. The Hunter Valley is, I think, without doubt, the premier thermal export coal basin in the world. I mean, what are you going to put up to challenge the Hunter Valley in terms of quality, cost, access to tidewater, et cetera, et cetera? Now, how much of that you can access domestically is a question, but I think there is, the way the Chinese would look at this is they'd say there's an obvious, and maybe this is why Yancoal is just paying $2.5 billion for coal and allied, right? Is there's an obvious synergy between the export business and the domestic. I mean, you've got